So today I'm going to be presenting to you my honors project, which was working with Dr. Bill Arnaud to undergo a lithological and geochemical analysis of deep marine turbidite systems. So we were looking at the Windermere supergroup of the Southern Canadian Caldera, which makes up a continental margin of turbidite systems, which are formed mostly of sediment sourced from the North American Craton. And so the strata within this region are mostly composed of siliciclastics, although we do see some interruptions of carbonate-rich intervals that in some regions are about a few hundred meters thick. So that really indicates the activation of an expansive shallow water carbon factory, which likely coincided with episodes of elevated sea level. And so we see these systematic and reoccurring changes in the stratal element composition of the sedimentary pile, and this suggests that there's repeated changes in the sediment supply, which in turn are controlled by the character of the turbidity currents that remobilize the sediment downslope and build up this depositional record. So there's very evident channel complexes being formed within the stratigraphic succession. And so the objective of this research was to determine if these short-term changes that we see within the stratigraphy, if that was the same within the chemostratigraphy. And so to perform this analysis, we took mud rocks from Castle Creek North, Castle Creek South, and the hill section, which are located over on Figure 1. And these were spaced about 10 meters apart vertically in the collection of the samples in order to create a 2.6-ish millimeter thick chemostratigraphic transect. And so the preparation of these samples involved pulverizing, calculating loss of ignition, which was used as a correction factor in our XRF analysis, as well as fusing the pulverized samples with lithium borate to create discs in order to be put into the instrument to undergo XRF analysis. And so what the XRF was actually doing was determine the minor, the major, and the trace element composition of each of the samples that we had selected. And so in Figure 3, we're showing an idealized stratigraphic compilation of the stratigraphy from Castle Creek. And so we start with Castle Creek South, and then it goes and fills in with the hill section, and then Castle Creek North is located just at the top of the succession. And adjacent to that are profiles for the elemental composition of strontium and zirconium, and that was obtained through the XRF analysis. And so the strontium serves as a proxy for the carbonate sediment production, and the zirconium serves as a proxy for the siliciclastic sediment input, which would be coming from the hinterland. And so what we were able to notice is that the strontium and zirconium are seen to be inversely related. We see that there's two episodes within the succession of elevated strontium levels, and the first is being associated with the first Isaac carbonate, so that's right at the bottom, the first HST you would see in Figure 3. And systems track essentially were flooding the continent, which is drowning the shelf and allowing for the activation of the carbonate factory. And then approximately 1.3 kilometers on top of that, we see this occur again, except this is a bit more of an abrupt change. And throughout these strontium increases, we see that the siliciclastics are remaining pretty constant and so not really changing. And there are some anomalies of strontium present within the data, and those were found to be associated with phosphite, associated with short duration events of elevated organic rich sediment input. And so the one thing that we noticed in this succession is that there was a lack of one-to-one correspondence between the lithostratigraphy and the chemostratigraphy. And so this is really just suggesting that there's alternative factors in addition to sediment production from the basin and downslope export that act to control the stratigraphy of the continental slope. And so in order to look at this further, more sophisticated analytical techniques like ICP-MS would have to be used. And in conclusion, looking at a relatively stable chemostratigraphic record, indicating that the changes in the lithology are a result of alterations in the sediment supply, which have yet to be discovered.